Salam sejahtera to Professor Dr. Asman bin Yassin and also my friends from the class Genetic Algorithm A192. So I'm going to present about our group project, Simple Genetic Algorithm Traveling Salesman Problem, also known as SGA TSP. And I'm going to describe a little bit about the problem. Traveling salesman problem has been given a set of cities and distance between every pair of the cities. The problem is to find the shortest possible route that visits every city exactly once, means that you have to visit every city once and then return back to the starting point in the shortest distance. And genetic algorithm can be implemented to find a solution for the optimization problems because you want to optimize the shorter distance to travel every cities. So in the following implementation, cities are taken as genes, and the string generated using these characters is called chromosome or population, while a fitness score is equal to the path length of all the cities mentioned, is used to target the population. And the algorithm is designed to replicate the natural selection process to carry generation, which is survival of the fittest of being, meaning to say the best will survive. And the standard GA are divided into 5 phases, which is to calculate the initial population, not calculate, create an initial population, and then you calculate their fitness, and you select the best gene, and then you do crossover to change the gene for the better offspring, or you do a mutation, or you do both. And fitness score is defined as the length of the path described by the gene. So the lesser path length, the fitter the gene, meaning to say the shorter system is the better one. And the fittest of all the gene in the gene pool survive the population test and move to the next iteration. So the number of iteration depends upon the value of the cooling variable. The value of the cooling variable keeps on decreasing with each iteration and reach a threshold after a certain number of iteration, meaning to say it is keep on decreasing fitness. If let's say the smaller the distance, then the better the fitness. So fitness will reach amount that the minimum distance has been arrived. So there's a fittest generation. And when you once arrive to the fittest generation, you got the shortest path. The solution has been solved. The solution has been presented. And so I'm going to present mainly on crossover. Crossover is the most significant phase in a genetic algorithm. For each pair of parents to be mated, a crossover point is chosen at random from within genes. What does it mean? I'm going to show you an example. Consider the following chromosome. So there's two, A1 and A2, and the cross point is to be as 3, meaning to say after 1, 2, 3, 0, 0, 0, and then you got a 3, you got a cross line there, and you cross between two chromosomes, A1 and A2, and you can see the cross point is in the middle because it's got six genes. So as you can see, the cross point is located at the middle, and afterward, offspring has been created by exchanging the genes of parents among themselves until the crossover point is reached. So yeah, we will do it in coding using a simple iteration for loop, and afterwards you got a new population, okay, new chromosome in the population. So A5, A6 have been created with a simple crossover point, just at changing the gene within the chromosome of A1 and A2. So there's two methods. One is single point crossover, one is a 2-point crossover, and also some others like multi-point crossover, but we will only be covering two crossover method. So the first one is single point. One crossover point is selected binary string from the beginning of the chromosome to the crossover point is copy from the first parent. The rest is copy from the other parent. So meaning to say you actually select a point within the chromosome itself. And then you using the point to divide it by 2 from both of the chromosome, and then you exchange their side, like parent A, the blue color and green color, and then parent B, the yellow color and pink color. So eventually the blue color and pink color will be merged and create a new offspring. There is a binary example, 1100100011 is one chromosome. The second chromosome is 11011111. So at this point, we have a crossover point at number 5. That's why after they have been doing crossing, they combine the part of the chromosome itself and then create a new offspring. So this is the crossover for single point. And for 2-point, crew crossover points are selected. Binary string from the beginning of the chromosomes to the first crossover point is copied from the first parent. The part from the first to the second crossover point is copied from the other parents, and the rest is copied from the first parent again. So 2-point is basically similar to single point, just that you have another point to cross between them. So you got three different parts, and then you use the first 2 parts from the parent A, and then merge with the middle part of the parent B. So yeah, it takes turns to merge together, and then finally you got a 2-point crossover offspring. So below is a very simple binary chromosome example, and then we will be using single point in this project to make sure it's simple enough to be understood. So this is a pseudocode. So it's very simple. You're doing a loop within the population. For each individual in the population, you create a new population in the array. And if the crossover rate more than the random digit, then second parent will be selected, and then the offspring will be being called by the method crossover. And then you insert the first individual and the second individual inside the crossover method. So the point will be selected inside the crossover method, and then both of them you will do a single point crossover exchange. Afterwards, you have a new offspring. So what do you want to do with the new offspring? You put it in a new population, meaning to say this first parent and also the second parent come up with a new child, and the child will be put into the next generation, and then do it all over again. If let's say the crossover rate is less than the random number, then the new population will push the individual instead of the new offspring. So random number is decisive factors here. If because crossover rate doesn't necessary to be always making sure that all chromosome has to be crossed. It is very simple that it is being decided by randomly. So the higher the crossover rate, the more frequent that the chromosome will be crossover and appear in the next generation with new offspring. So the loop ends. And this is our program. Our project has a crossover class. How does it work? So as you can see inside the method of the X over, which is crossover, we accept 2 parameters, crossover 1, crossover 2. I mean chromosome 1, chromosome 2. Initial point is 0. We're going to decide how do we choose the single point to be crossed later. And the bilangan generation number is 8. By default, it is a fixed number. And we have a temporary variable to make sure that we can later exchange the divided part of 2 chromosomes. So in this example, bilangan generation is definitely more than 1. So we can straight away jump into the if-else statement. And if let's say the bilangan generation is equal to 2, the point will be strictly equal to 1, meaning to say we cross at the first gene on the chromosome of 1 and 2. But for this one, we have a bilangan generation of 8. So we go to else. Else point equal to my random dot in random build gene minus 1. So meaning to say we're going to have a random point to be generated later in my random class. And then we'll be inserting 8 minus 7, bilangan generation minus 8 minus 1. So bilangan generation equal to 8 minus 1 is 7. 7 put inside the random class and then come up with a random point. So after we have the point, we use a simple iterative loop example, loop code. The fragment of the code is like for in 1 equals 0 and then I less than point. Let's say the point is 5, so I plus plus, and then we use a temporary to store the loop example. So for first one chromosome, we store it inside the temporary, and then we set a new gene again for number 1. And so how do we set? We choose from the number 2, the chromosome number 2 at the 0.5. So after 0.5, all the gene behind number 2, right, will be put inside number 1. And then number 1 also do the same, swap inside number 2. So this is crossover, how crossover have done inside. And then we return the point. And we have a simple output here. So let's say the chromosome 1 is 3X724955X7, and chromosome 2 is 0757292873. Bilangan generation, as I mentioned, is equal to 8, and the point is decided by the random class, and the bilangan generation is 8, so 8 minus 1 is equal 7. Let's assume the random return number 1 because the integer random method itself is actually using math.random function. So this function will return either 0 or 1. So let's assume it return 1 lah, okay? So point inside the my random class, we have a formula like this. So if it return 1, so 1 will be times 8 minus 7, meaning to say 1 times 7. So 7 plus 1 equal to 8. So we're going to cross our point at gene number 8. So as you can see, I drew a line on chromosome 1 and 2, and our output, the offstring, will be replacing the last 2 gene with between 2. So originally we have chromosome 1 as 3X724955X7, but now the X7 becomes 73, and chromosome 2 originally 0757292873, but then we cross over, so 73 become X7. Where is the 73 go? It go back to chromosome 1 already. So 2 more new offspring will be generated in the new generation. So this is how we constantly doing the crossover, and then afterwards we will be using the new crossover. After crossover, we have a new chromosome. The chromosome will recalculate their fitness again. So the shorter the distance will be chosen into the next generation. So crossover can help us to generate more varieties of the output, and then make sure that you have a shorter distance at the next generation, and then keep on trying, and lastly we get the optimized output. So this is crossover. Thank you very much. Now we will be moving forward to the last part, mutation. Thank you.